This one is talking about the speed.
Yep.
If you want to know the speed, what do we need to know?
The distance and the time.
Thank you. Yes. Distance and time. That's the basic knowledge we already learned. Speed equals distance divided by time. Now, the question asking us is, what is the fraction of my normal speed did I work on average during the slow part of the journey? What is the fraction of normal speed did I walk on average during the slow part? Then the fraction, since that is a fraction, right? We have numerator, denominator.
Yep.
The fraction of my normal speed. So what's that mean? What's that by mean fraction of my normal speed?
Fraction of your normal speed would be, so you took 24 minutes
Yeah.
to walk the whole journey.
Mm-hmm.
And
The fraction from my normal speed. My question is, for numerator and the denominator,
yep.
My normal speed should be on the numerator or should it be on the denominator?
What fraction of my normal speed did I walk? It should be during your slower part of my journey. It should be the numerator.
You mean you mean the normal speed should be on the numerator?
During the slow part of my journey. Sorry, no, denominator, because you're finding out a part of your normal speed.
Exactly. Just like I said, what's the fraction of mom's age? Right?
Yeah.
Yeah. It's your age on mom's age.
So my age.
Another fraction. Mom's age should be on the denominator. Your age should be on the numerator. Then I get a fraction, right?
Yeah.
Compare your age to mom's age. Okay. So here should be the normal speed. Here should be the slower speed. That is how we get the fraction, right? That is actually what we are after.
Okay.
Yeah? Okay.
Yep.
Since we want to align the speed together, look, speed equals to the distance divided by time.
Speed equals, yep.
Yeah? And then now let's read this question. Usually it's taking me 24 minutes to work from home to office. Today, I'm working 3/4. Let's draw it. 3/4. Oh, sorry, it's a little bit. Let me draw it a little better. So 3/4. Today I'm working 3/4 at normal speed, right? This is 3/4. Yeah.
Yep.
And then last quarter instead, because the road working slower, and the whole work took 4 minutes longer.
4 minutes longer.
Yeah. So they all talking about is the slower speed. So that slower speed is only happening for the last of 1/4 of the road, isn't it?
Yes.
Okay. If we want to know the speed of the slower speed and the normal speed, we need to find out the distances and the time for that last 1/4.
Okay.
But interestingly, we find out the distance is the same. It's last 1/4.
Last 1/4.
No matter you're working at the normal speed or slower speed, the distance are same.
Yeah.
Isn't it?
Yep. And then for like to compare it, wouldn't you do 24 minutes to walk the whole thing?
Yeah.
So 1/4 would be 6 minutes.
Exactly. That is normal. This is normal. 6 minutes.
Yeah.
But now, because you're walking slower, how many minutes you take now?
4 more minutes. So that's 10 minutes.
10 minutes? That is for slower.
Right. And then that means it's what fraction of my normal speed did I walk? What fraction of my normal speed did I walk on average during the slower part of my journey.
When you see this
So,
formula,
yeah,
did I teach you? I'm not quite sure, but I do teach some students in the earlier semester. Like, Misha, look, check this formula. Actually, this formula, what I'm going to tell you is not only applied to this formula. Any formula, like equals A equals another two numbers is do the division, it all works is, look, every time. Did you see the distances and the speed? If you look at the distance and speed, they are changed on the proportion way. When I say the proportion way, which means if the time no changing, your speed doubled, then your distance doubled. Is that easy to understand?
your speed doubled.
If time is the same.
If the time is the
speed is
same,
doubled,
but your speed is doubled,
your distance is doubled.
yes.
Because
Okay.
they are, this is what I say, they are changing in the same direction, right? This is called, yeah, the proportions, right?
Oh, okay.
But
So
look at the speed and the time.
speed and time.
The distances equals to speed
Speed.
times time, right?
Yep.
If your distance is not change, when
Distance
your
doesn't
speed doubled, your time
speed doubled, your time divides,
halved,
halved by
right?
2. Yep.
So which means they are changing in the opposite way.
Oh, wait, okay. So if you have speed equals distance over time, your time stays the same. Your speed increases, so will your distance.
Will be increased the same times like your speed.
Okay.
That's easy to understand, right? I
Yep.
give you 1 hour. You're driving 30 kilometers per hour. So 1 hour, you're driving 30 kilometers. If
Yeah.
you increase your speed into 60 kilometers, but still for same hour, you increase to 60 kilometers. Easy.
Yeah. Okay. Yeah.
Right? Yeah.
And then for the other one, distance equals speed multiplied by time. If the speed goes
Up,
up,
time goes down.
time goes down. Yes, because if, for example, 1 second, down.
If the distance is no change, okay? If the distance is the same, your speed going up, your time is going down. This is why every time when you're late for school, you always ask mom, driving faster. Why?
Because your time will go down.
Yes, the speed, the distance is the same. The distance between your school and your house is always no change.
Yeah.
You're driving faster, your time is taking shorter. That's why people always driving super duper fast. They over speed. They want to
Yeah.
shorten their time. Yeah. So
Yeah.
look here. If the minutes, so the normal time I only use 6 minutes. Yeah.
Yeah.
Okay. That's my normal time is 6 minutes. The slower time is 10 minutes, right? So that is gonna be 5 out of 3. But be careful, this is your time. Your slow time compare with your normal time. Now we want to know if the slower time compared with the normal time is 3 to 5. How about speed then?
Wait.
Timer, I'm sorry. It's time. It's supposed to be time by timer.
I'm confused. Why is it 3/5 then, not 5/3?
That is the time. Because the last section, your slower time is 10 minutes.
That's the time, not the speed.
Yes. Your slower
Oh.
time, you need 10 minutes. Normal time, you only need 6 minutes. So 6 out of 6, 10 out of 6 is 5 out of 3.
10 out of 6. 10 out of 6 is 5/3.
That is your fraction for your time. That is the fraction of your time. Your slower time
Yeah.
of your normal time.
Okay, so so it's not the speed, it's the time.
Yes. But
And
how
now we want to figure
speed?
out this speed.
The speed should be
Distance divided by time, and the distance is 1/4.
distance
Right?
is the same. So your speed and the time gonna be
Wait. So the distance is the same,
when distance is the same,
speed and time,
they are changing they are changing the different way.
different way, different
So
direction.
which means this one is supposed to be equal 3 out of 5.
Oh, because so the distance
Then when
both
they
of
come
them.
together, they will be equal. The distance is the same. This all equals to 15.
Okay.
Mm.
Oh. So distance is the same, but your speed and time okay. Speed, time, opposite directions. Opposite. That makes sense.
Right?
Yep. Okay.
So their fraction about speed and time, this should be reciprocal. Right? This should be reciprocal. This should be like a reverse. They just change the numerator and denominator upside down. Then when you time together, they are still equal because the distance is never changed.
Yeah. Okay.
Yeah?
Wow. Okay. Yep.
Okay. So that is how you get more deeper understanding about all these type of the formula. Let me give, if you understand this one, let me give you another example. Any other formula you learned that got the similar format of the one about the speed and distance time? I can give you one example. Average equals
Total number.
divided by number of the item. Remember?
Yep.
Right? That is
Yep.
very similar to the speed equals the distance divided by time, right?
That is, yeah. And then
Same thing. Same thing. Same thing. If you got the numbers item the same, you increase the total, which means your average will be increased.
yeah.
You got
Okay.
10 children. Yeah?
Yep.
10 children. Their total age is 100, which means their averagely they are 10 years old.
Yep.
Now the total increase doubled, increased to 20, increased to 200. How about the
That
average?
means 20.
Average doubled from 10 to 20. Look, same thing.
Yep.
Yeah.
Yep.
They change in the same way, isn't it?
Yeah. And then the number of the items stayed the same. Wow.
Yeah.
That makes sense.
We call it proportional. Proportional means how much you change, how much I change. We change in the same way.
So proportional, does that only apply for this one? Like when the distance and the speed are the same? Or is it still called proportional when they go up? And then is it still called proportional for the speed and the time?
I need this format. I need this format. Look.
Okay.
A and C, they are proportional.
Proportional.
Proportional means you increase double, I increase double. But be careful, Misha. Not addition, okay? Not to say you increase by 10, I increase by 10.
Yeah.
No, that doesn't make sense, okay?
No.
You increase twice, you doubled, I doubled. You half, I half.
Okay.
Okay?
Yeah.
And then, yeah, in other words, we say the B and the C. These two, because we know A equals B times C. So we know B and C, they are inverse proportional. Inverse proportional means they change in a different direction. If B doubled, then C only halved.
Okay. And this also applies to ratios, right?
Yeah.
Okay.
Anything, if you can write in this format, it all works.
Mm. Okay.
This is just some understanding about this type of the triangle formula. It all works. Yeah. Think
Yeah.
about it. If you only got 100 of the marbles there, you share with 10 students. Each one have 10. If I only got 100 total, no change. I
Yeah.
share with 10 students. I know that averagely everybody can get 10. If I increase this number from 10 to 20, I doubled it. I doubled the number of the item.
That means your average is half, which is 5. Wow. That works.
Yeah.
Yep.
So just now for this question, you know why it's 3 out of 5, because their time is 5 out of 3.
Mm.
So their speed gonna be 3 out of 5.
Okay.
Okay.
Yep.
And also for this question, but I don't think you should have any problem to understand what I told you. But some of the students, if they really have this difficult to understand about this different proportion or inverse proportion problem, the relationship, what I also can suggest them to is just make up one of the distances. You just set up the one of to say like a 72 or make it 96, as long as it's a multiple of 24. You just make up one.
Okay.
Yeah, then you just using that distances to calculate it. What is the fraction of what is the distances, what is the speed of the normal, and what's the speed of the slower. Then you can get the fraction. That's also
yeah. So which one would you recommend?
Of course, this one, if you understand.
Okay.